Solving quadratic equations by factorising. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, c are constants and a is not equal to 0. Factorising a quadratic equation means rewriting it in the form px minus q times rx minus s equals 0, where p, q, r and s are constants, p is not equal to 0 and neither is r. Solving quadratic equations by factorising relies on the fact that if px minus q times rx minus s equals 0, then either px minus q equals 0 or rx minus s equals 0. In the first example, x minus 3 times x plus 7 equals 0. This means that either x minus 3 equals 0 or x plus 7 equals 0. If you look at these two equations and solve them, we get x is equal to 3 or x is equal to negative 7. And they're our solutions. With our second example, 2x times x minus 8 equals 0. Again, this means that either 2x is equal to 0 or x minus 8 is equal to 0. If we solve each of these equations, we get x is equal to 0 or x is equal to 8. And in our last example, 2x minus 1 times 3x plus 5 is equal to 0. This means that either 2x minus 1 equals 0 or 3x plus 5 is equal to 0. Solving the first equation, we get 2x is equal to 1, and that gives x is equal to a half. Now we can actually solve these quite easily by inspection. So if we look at the next one, 3x plus 5 equals 0, you think what value of x will make this equation true? Well, x is going to equal negative 5 on 3, because if we multiply negative 5 on 3 times 3, the 3's cancel out, we get negative 5, plus 5 is equal to 0. So you're going to be able to solve these by inspection after a bit of practice. The next three equations need to be factorised first in order to solve them. Example D, x squared plus 4x plus 3 equals 0. If we factorise this, we get x plus 3 times x plus 1 is equal to 0. And now we use our method x plus 3 equals 0 or x plus 1 equals 0, and we can read off the solution once we get good at it. X is equal to minus 3, that'll make the x plus 3 term 0, or x is equal to minus 1, that'll make the x plus 1 term 0. Alright, x squared minus 49 equals 0. When we factorise this, gives us x plus 7 times x minus 7 is equal to 0. It's the difference of two squares. And that'll give us x is equal to plus or minus 7. An alternative way to solve this, and one way you may have done before, is to change the equation to x squared is equal to 49. And x is equal to plus minus 7 is a solution. This is not using the factorising method, but it's perfectly valid. And finally, 2x squared plus 9x minus 5 is equal to 0. Here's an example of a non-monic trinomial, so you need to be good at factorising. This factorises to 2x minus 1 times x plus 5, and that equals 0. And again, we can solve each of these equations really by inspection. X is equal to a half or x is equal to negative 5. Alright, the last three equations. What's different about these? You'll notice the quadratic equations have terms on both sides of the equal sign. And the first step when you see one like this is to gather all terms on one side. So x squared plus 4x is equal to negative 4. First needs to be made to look like this. We added 4 to both sides, so the right hand side becomes 0. Now we proceed in the normal way. X plus 2 all squared is what it factorises to, and this means there's only one solution here. X is equal to negative 2. 5x squared is equal to 2x. Again, we need to first gather all terms on the left hand side. We get 5x squared minus 2x is equal to 0. And we factorise this, and that gives us x is equal to 0, or x is equal to 2 on 5. Some students want to solve this equation by dividing both sides by x. That means we get 5x is equal to 2, x equals 2/5. You may notice that that does not give us the x equals 0 solution. That's because when we divide both sides by x, that only works if x is not equal to 0. So don't do this. And finally, 6x squared is equal to 5x plus 6. We need to transform it so that all terms are on the left-hand side. And here's where you have to be good at factorising non-monic trinomials. This factorises to 2x minus 3 times 3x plus 2, giving us the solutions x is equal to 3 on 2, or x is equal to negative 2 on 3.